Okay, well, apologies for not being in person this week. We will return to Zoom in person next week. I just had a commitment that I've had for months that I really can't get out of. So, apologies, but I'm going to go through the two Excel problems for this week. So, hang in there. Okay, well, this one here, I got the instructions. I'll refer back to it as needed. But, this particular one is going to deal with the federal budget in 2019. And really, you can think of this as like your own personal budget, right? Mandatory spending is things like that you have to do at home, like buy food, pay the electrical bill, mortgage or rent, whatever you got. And discretionary spending, and that's like, this is what is mandated by the federal government. Social Security, Medicaid, Medicare, and the other is thousands of items. And these are not dollars, these are billions of dollars. So in 2019, Social Security would be over $1 trillion, right? $1.046 trillion. And then you see the others. Discretionary spending is spending that needs to be approved every year by Congress. Non-defense spending, again, is thousands of things, right? So it's just broken into broad categories. You can think of this as like going out to eat or going to the movies or whatever you do with extra money that if you might have. Interest is, again, it's an expenditure. These are all expenditures. Interest is an expenditure. It's $363 billion. What that is just paying the interest on the $30 plus trillion federal debt. So it's like if you had a credit card, you ran it up all the way to the max and you're paying it just the interest every month. That's what the government's doing here. Receipts are income, right? Expenditures and income. Income is income tax, corporate taxes, payroll tax. That's like FICA, 6% for Social Security, and then 1.5%, whatever it is, for Medicaid, Medicare, and these are other taxes that are paid. So this is the money coming in. This is the money going out for this year. Okay, so the first thing we're going to do with this file, when it goes, it's got a couple of graphs down here, and I'll go through it. What's nice about this, you can at least pause it as we go along. So the first thing I'm going to do is find the subtotals for each category. So the subtotals for mandatory spending, I'm just going to type in equals the sum of these cells here. And that's $2.7 trillion mandatory spending. The subtotal here is just the subtotal of discretionary spending. And this one I can just put equals, actually it can go this plus this. There we go. This one, there's only one category in interest, so the subtotal is the same as what you spent, which is just that. So we'll do income first. We'll do outlays, expenditures first, then we'll do income. All right, this is going to be a percent here. It's asking you what percent of the subtotal is Social Security. So, and they wanted here, compute it 3 decimals as a decimal to 3 places, and here as a percentage to 1 place. So this is going to be part divided by the whole of the subtotal. And that is 3 decimal places, I think. And that's what it said to do, so that's good. And then here is simply going to be this made into a percent, which is already right there. Otherwise, you'd have to change it to a percent. Now, these you can just drag down because this is what you're getting, right? Oh, I must have made a mistake. Anybody realize what mistake I made? Yeah, how about this? This D13, this subtotal is not going to change, so you have to lock it. You know, I just lock them all up. And this one here, it doesn't, no, it doesn't change because it just refers to this one here. So that should solve the problem. And it does. So what this is saying that of all mandatory spending, 38% of it is Social Security, 22.8% Medicare, Medicaid, and all the others, which is thousands, right? Okay, so let's do discretionary spending. National defense is going to be equal part divided by total, and the total we're going to lock this time so we don't make a mistake. And this one is going to equal 52%. Now these two we can pull down because these are percentages of the subtotal, right? And for this, the percentage of a subtotal here for interest is going to be 100% because the subtotal and the total and interest are the same here. So they didn't ask for one. So here, they also want the percent of the total. Well, for here and here and here and here. So what percent of the total are these items here? These items of expenditures. Well, we better get the total first. So we're going to put the total here. So this total is going to equal the subtotal here plus the subtotal here plus the subtotal here. There you go, 4.407 trillion. So we're going to do the same thing here and here as we did over here, only we're coming off the total. So the percent of the total for Social Security is Social Security expenditures part divided by the total expenditures. And then, whoops, again, you better lock that because this isn't going to change for any of these. So that H19 needs to be locked somehow. And this will not need to be locked because that's going to be... This is telling you that of the total amount spent, of the 4.4 trillion spent, 23.7% of it went to old people like me. Ha! That's the way it goes. Maybe it'll be there for you. Okay, so that's, I just had to pull down. I don't know what it's showing me there. Should be correct though. This one is going to equal part of the total, and I need to lock the total. And that I can pull it this way first, and then I can pull it down. And it doesn't, I don't know, why did it do that? B15. Oh, because I got caught up in here. Maybe, I don't know, let's redo it. Part divided by total. Locked. That equals that. Only this needs to be a percentage with one decimal place. So let's go to home. Apparently on this one it didn't give me the percentage. And one decimal place. And this one here needs to be home, percentage, one decimal place. Alright. So national defense was 15% of the federal budget. That's what that's saying. And this one here is the final one, is interest, right? Interest on the debt. That money just goes to pay for the interest, like your credit card, if you don't pay it off every month. Lock that, right? And should be able to pull over. And I don't know why it does that. that works. And just redo those like that. I don't know. But it all works. It's all good now here. Now we're going to do the same thing with income, right? These are expenditures. Now this is the federal income. And first thing we'll do is we'll get the subtotal equals the sum, right, of these categories here. Boom. And the total, I don't know, the total to me is the same as the subtotal because I don't have anything but one subtotal. So the total in this case is the same as the subtotal. So these are all going to be the same, right? The percentages will be the same because it's the same thing. Alright, so for income tax, part to subtotal. And lock that cell F26, right? Or D26, that needs to be locked because you're going to drag this down. So let's drag it down. And here, let's make these into a percentage. And it's made into a percentage that way. It should be able to just drag these down, which I can. Alright, what should all these add up to? Anybody know? Extra thing. All the receipts, all the income, what should it add up to? 100%, right? Okay, so this is percent of the total, which is basically the same as the percent of the subtotal, because we only have one subtotal. We gotta lock that one, right? Like I said, you can pause this too anytime you want. And we go down there. And this should be this. And they have it as that. If you do it that way, you don't have to do what I did here probably. And again, of course, these match because they only have one subtotal. Now they're going to have, we're going to have pie charts here. All right, pie charts. Well, I'm going to stop talking like for a couple of seconds here and get a little coffee and come back, but you won't notice. And then we'll do this. Okay, for the bottom part of this, they're giving you the outlay categories. They want you to put in how many billions were spent in each and then make pie charts for both expenditures and for income, right? Money going out, money coming in. So it says, here, I'll move this over a little bit maybe. Oh, I really can't. Let me see what I can do. I can move it up and down, it's good enough. So what you can't hardly see over here, but this is the money, the outlays, right? Let's see if I can expand this a little bit. Alright, so down here we're putting equals B9. Because that is the money spent on Social Security. Now I can drag this down to other, but then I got to stop and redo it. So I can just drag this down through other. Gives me the expenditures which match up with up here. And then national defense is going to equal whatever this is, 678 billion. And I can drag that down one to non-defense, and then I'm going to have to do interest separately, which is right here, B18. Alright, so I have the amount of money spent for each of these large categories. Some are just one category and some include thousands of separate items like other, but they're grouped together, right? So income tax is right here, and I can drag that down all four. All right. First, let's do this E here before we do the charts. E is the amount of surplus or deficit. Surplus means that you earn more than you spent, and deficit means you spent more than you earned. So if you take the total amount of money that you earned, right? Think of your income and subtract the total amount of money you spent. If the number's positive, it'll be a surplus, and if it's negative, it'll be a deficit. Hope that makes sense, right? Pretty simple. So the total earned was here, minus the total spent, which is here. And that's, yeah, in red, in parentheses in red, means that was almost $1 trillion that we spent as a country more than we earned. Yeah, not good. All right. Now the debt F, as it says, assume you're getting charged 2.5 APR on the debt. Compute the debt using the interest given in the table. All right, I'm going to go over this a little bit more detail by hand. So I'm going to cut it out here and come back over it. What I'm going to be using is this number here, 363.4 and 2.5%. And I'll go over what that means. Okay, so this is the interest paid, right? And that year, what was it, 2019? Paid that much interest, 363.4 billion. That was the APR. That's what you paid on the total debt. What you're trying to find is the total debt. So I'll do it algebraically first, right? My total debt, I'm going to say the total debt times 2.5% is going to equal what you paid in interest, 363.4. All right. Remember, you can't use a percentage in math, or you got to change this, put that what it is. So the total debt, make it a decimal, 0.025 equals 363.4. Divide both sides by 0.025. And now we'll need a calculator. And I have one somewhere. So it's 363.4 divided by 0.025. I'm getting 14,536, which is billions, which would be 14 trillion. 14 and about a half trillion dollars in debt as of that year. So let's go back and put that in. So we did this on the webcam, so we'll do it here in Excel. The total debt is going to equal the interest divided by, you could use in Excel, you could use percentages and it automatically changes it into a decimal. And there it is, $14 trillion as of the year, which was 2019. All right, so now we'll go to the graphs. Here is the graphs. Of course, I'm too lazy to label them, but I'll let you can do that. So the first one, well, we're not getting the whole thing. Let me rearrange the window screen. Okay, I think I have this screen good now. So what we're going to do is make a pie chart here of this, which is, we're going to call right here, you want to retitle it U.S. budget outlays 2019. Alright, so we're going to highlight this, just the category and the money. We're going to go to Insert, Recommended Chart, Pie Chart. I'm going to put that here. I'll fit it in a minute. Then we got to go up to Chart Design, and it says Apply Style 4. 1, 2, 3, 4. That's Style 4. And then it says under Quick Layout, which is over here, top left, right? Quick Layout. Layout 6. 1, 2, 3, 4, 5, 6. Alright, now the only thing you're going to have to do is put in the title. Okay, so let's go to the second one, which is under Receipts. Highlight, don't highlight that C, just individual taxes. Those are the 4 categories. We're going to go to Insert, Recommended Chart, click on the pie chart, and you can put it, well, I don't quite have enough, well, I have enough space if I do this. Put it here. Then we're going to go to Chart Design, right? You need chart tools. Chart Design, Design 4, 1, 2, 3, 4. Click on that, and then go to Quick Layout, and you want Quick Layout 6. 1, 2, 3, 4, 5, 6. And notice it's giving us the percentages. I'll move it over a little bit. I don't quite have it in this thing, but it gives you the percentages. Change the chart title to U.S., but don't forget the periods. You know, it's got to be exactly as it is. U.S. Budget Receipts 2019. Okay, so that's the first one. Oh, how do I get out of here? Where am I? Okay, here's our second Excel file for the week, second and last. And what this is the year and then the annual CPI, right? So the way you can look at this, they usually standardize this to some year, usually 1985. So this one is standardized to 1983. So that's about 100 in 1983. Right? So you can look at it this way. $100 in 1983 has the same purchasing power as $9.90 in 1913. I'll do it one more time, right? What cost $100 in 1983, you would need $270.97 in 2021 to have the same purchasing power. But of course, wages go up, right? If you listen to, well, you can listen to me, like, yeah, back in 1962, I only made $1 an hour. Well, yeah, I only made $1 an hour, but you know, I would need $30.20 to have the same purchasing power as it takes you today, over probably $290, right? So it's all relative. Over time, the standard of living has gone up. So, but here we go. So the total change is just simply the difference between 1914 and 1913. Just the total difference. So all we're doing here is going 1914 minus the CPI in 1913. So that's what the total change is. I don't need to lock any cells. I can just drag this whole thing down now. Bottom right, where is it? There it is. Boom. Alright. Boom. That's the total change. Now we're going to do the percent change. Right? The percent change, and you should really put this on your card for the test, because you're going to be asked to do a percent change, and specifically on this stuff too. They'll say, hey, if the CPI was 10 in 1914 and 9.9 in 1913, what was the percent change between these 2 years? And the percent change between the 2 years is nothing more than what you call inflation, right? The inflation rate. The annual inflation rate, which is targeted to run about 2%. It's now running about 2.5. A few years ago it was running about 8 or 9, which was bad. Worst inflation since the 1980s. But maybe you can see that in the data here. Alright, so percent change is new minus old divided by old, right? That's new minus old, total change, right? New minus old divided by old. And we're going to leave this as a decimal, and it says to 3 decimal places. And then we're going to turn this into a percentage and to 2 decimal places, and that's what it's got right now. So let's run this down. I'm actually going to run down together. And you got all of the annual inflation rates. It was really bad during here, World War I. After that, it actually went, that's deflation. Prices went down 10.5% between 2020 and 1920, 1921. And remember I was telling you right after, yeah, well they only have the 21, but in 21 it was 4.7. It got worse in 22 and 23. And now, like I said, it's running about 2.5%. The last time it was really bad was in the 80s. Yeah, here, 79, 80, 81. That was during the Arab oil embargo. Energy is a big contributor to all of it. Look at all this inflation. It was due to the Arab oil embargo, and it was also due to the fact that demand from the baby boomers forming households was outstripping supply. So you had 2 things going on here. Alright, so now they want z-scores. Well, a z-score is data minus the mean divided by the standard deviation. So you have to do that for these columns. Let's see what they want. Percent per 10 year, compute the total change, percent change, compute total change CPI, rolling 10 year, that's over here. 10 scores, compute the mean and standard deviation. So do they want the total percent change, or they want the total change, or just, let's look at the instructions to see. I don't think it makes much difference, but how to calculate the mean, let's figure it out. What cell is that? We're looking at cell, whoops, cell D117. Calculate the average CPI form. Annual percentage change. Annual percentage change. Annual percentage change. Okay. So for the mean, we want the annual percentage change, which would be here. So we got to start it out anyhow. Equals the average and the average will be from here. What if I start here? Won't matter. No, it doesn't matter. Blank cell is, they don't consider it. So I'm using the white highlighter. Go all the way to 21. And there's the average percentage change. And the standard deviation, the average distance from the mean equals STDEV I'm not sure I have this exactly right. I think it's the same thing though. This is. And let me see how they want these formatted. And that would be, what is that? Geez. That is E117 and E118. Percentage change format as in E117 format as percentage of 2 decimal places, and D18 3 decimal places, E18 standard deviation percentage, decimal percentage. Okay, so I'm pretty sure this is decimal, and you just want this as a percentage, and I don't know how they, and standard deviation E18, E19, E17, that's 10 year. Standard deviation in 18, E18 as a percentage, 2 decimal places. So this one is just, like I said, it's that, boom. So the average inflation rate is 3.32% and the standard deviation is 4.71%. That's the average distance from the mean, right? Standard deviation. So z-score is going to be equal to the data. I'm going to data. Well, you need an equal sign, don't you? Equals, I'm going to put it in parentheses, the data minus the mean, close parentheses, divided by standard deviation. And there it is right there. Data minus the mean divided by the standard deviation. And these things aren't going to change, so I'm just going to lock them up. I know Chris might lock just, oh well, you're dragging down, so you don't really need to lock the letter. Well, I don't care. So what this is telling you is that there was less than just a half of a standard deviation in the change between 1913 and 1914. And so these are locked and loaded. They can go. So the bigger the number, the larger the distance from the mean. Like I said, back in the 80s, right, that's 13.5% inflation rate. That's over 2 standard deviations away from what the average inflation rate was. All right, now this one's doing total change for 10 years. So they're looking at the difference between the 10-year difference between here and here. So the total change over a 10-year period, a 10-year difference was the difference between and place the CPI here minus the CPI here. And now you can just drag down because it'll go this minus this, and then this minus this, and then this minus this, and then this minus this, etc. So that's the total change in the CPI. So, in other words, you can kind of look at it like it cost $6.9 more in 2022 than it did in 1913 for the same basket of goods, right? That's the total change. But, you know, we really need a percent change to really make sense of it. Good, I'll tell you why. Well, let's run it down, right? So you got that, B16 minus B7. You can always, obviously, just pause. I'm dragging that down to the end. And it looks like, oh my gosh, this one between 2011 and 2021, or 2010 and 2012 and 2021, you need $41.40 more to buy the same amount of stuff, right? The same basket of goods. Now, of course, the basket of goods changes over the years. I mean, back in 1913, there was more horses than there were cars, right? So it changes, but it's accurate in many ways. So just because the change was more here doesn't mean the percent change was more, because you're dealing with big numbers, right? Here's the numbers you're dealing with versus the numbers way back here. Alright, so the percent change is going to equal new minus old divided by old, right? That's percent change, and that's 3 decimals, and that is supposed to make it a percentage. So it increased by 69% between the decade of 20s to 1913. Now I can drag this down all the way. And, whoops, one more. Alright, so, you know, here's what I was trying to explain, right? This went up $6.9 between 1913 and 1922, right? 69, but it's 69% difference. That's a lot of percentage change. Whereas, going way down the bottom here, between 2021 and 10 years before then, so this decade here, it went up 18.2%. So when you get like 117%, that's doubling, right? Hopefully your salary's doubled then. Alright, so that's that. That's looking at decade-long time. So the mean, we're going to follow the same logic as here. I think it's going to be the same thing. I'm not even going to look. So I'm going to find the average of this percent change. Why is it doing that? Oh no. Oh my gosh, look what's going on. You ever have that happen? Like, I know it's a circular argument, I just made them. Okay. It's not, that's just going to be that. Percent change is going to be equal to this here. Alright, back on track. Restart this one. Equals the average of all these percentages. There we go. And and this will be the percent, right? So the average percent change in the CPI, the cost of living, was about just almost 34% every decade. That's the average average amount of inflation every decade, right? And the standard deviation using the same change here, right? And just this column is as a percentage. The percentage was the standard deviation. The average change was 31%. The average was 33%. That's the average that each decade increased their inflation by. And that's the average change, 31%. Obviously, it's got to be more volatile than a year-by-year basis, right? So the z-score is going to equal data, I'm going to put it in parentheses, right? The data minus the mean, which doesn't change. I'll go do that in a minute. Divided by the standard deviation. And let's go up and put in our locks. And I just always lock it up. It doesn't matter. So in other words, this was a little bit large. This is over a standard deviation larger change than the average change between the two decades. And run this all the way down. And there we go, right? The largest difference in this was, like I said, in the 80s, right? Over 2 standard deviations difference. All right. Now it says make a column chart of the individual inflation rate over the years given. Use the following title: annual inflation rate. So I'm doing this one, right? Let's shift back here. Let's look, see any special instructions. Clustered column chart. We're using the inflation rate, not the CPI. They're related, but they're not exactly the same. The inflation rate is a percentage. And we're going to use a clustered column with supply style 6. We get on our axis label and A to A, select the range, annual inflation rate, with charts. Okay, well, I'm just going to wing it here. I don't like reading all that stuff. So I'm going to do annual inflation rate. I can't just do this, I don't think. This is the annual inflation rate. And I think I'm going to hit Control key and do this. So I grab those 2 columns. And then I'm going to insert recommended chart, looking for a clustered column. Is that it? Yeah. Clustered column. Drag it up here. Oops. Try to make it fit, right? You probably can't see that all the way there now. Well, I'm going to stretch that way out. Makes sense, so you can read it better, I guess. And you want Let's look at the instructions one more time. Apply style 6 on the design tab. There's what you want to title it, annual inflation rates. And that's 1 year to the next. So I want this, my chart design. You know, if you can see it up there, I'm under chart design. And now I'm going to apply style 6, 2, 3, 4, 5, 6. You probably can't see that, but you'll figure it out. Alright, so that means prices went down 10% in this year, right? Between this year and that year. And so there it is. Beautiful. Just title it like it says, and should be good to go. Be in person next week.